Hello, everyone. Today we're talking all about target 2.1, which is the first target in our unit 2. Now, as we're starting to kind of investigate what's happening between parallel lines and transversals, today especially is where we're a little bit different than yesterday because we're actually working with truly parallel lines. Now, in our diagrams, usually what you guys will see, so if I look at my diagram right here, now when we talk about parallel lines are lines that go forever in the same direction and never actually cross each other. So when we talk about parallel lines in our diagrams, one notation that you guys will probably get used to seeing is usually we'll put little like arrows on each of those lines. And that is a way your diagrams will tell us whether or not our lines are parallel or not. Now, there could be more. I could put 2 little arrows on there, and that doesn't change the fact that those lines are parallel. Now, we learned a new word yesterday when we talk about transversals. Transversals are the lines in our diagram that cut through the lines that are parallel. So when we talk about 2 lines being cut by a transversal, some special things really ultimately end up happening for us. And a lot of times what it does is it ends up making angles either congruent to each other or supplementary with each other. Now, some of these, we don't necessarily even need parallel lines to even figure this out. When I look at my first set of angles here, when it talks about if you have 2 parallel lines that are cut by a transversal, then the option A says linear pairs postulate. Now, this doesn't have anything to do with parallel lines. This simply just states that these angles are supplementary. So any 2 angles in these diagrams that are next to each other and form a complete straight line are angles that would truly end up being a linear pair. So for example, if we were going to list one out here, if we're going to talk about a specific example, we would say, for example, angles 1 and 3 are an example of a linear pair because they're next to each other and they make up this line right here if you put those 2 angles together. Now, a couple other ones, we could jump down. We could say, for example, angle 6 and angle 8. Those are another example of a linear pair. Vertical angles, now these guys are always talking about lines that are crossing. So for example, I can't talk about any of these angles 1, 2, 3, or 4, being vertical with any of these guys because they're not even part of the same intersection. Vertical angles, for example, now these guys, no matter where your lines are going to be, these are always congruent. All right. Depending on where they are. Now, for example, if we're looking at a couple different vertical angles in this diagram, we could say, for example, that angle 2 and angle 3 are an example of, angle 2 and angle 3. Those are an example of angles that are vertical because they are part of the same intersection and they're across the intersection from each other. Now, we could also say, for example, angles 2 and 3 are, but also angles 1 and 4 also are. Same thing with angles 6 and 7 and angles 5 and 8. So when we have lines like this, now, some of the new relationships that we're going to look at are the next 4. We have what's called corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior. Now, yesterday we looked at what all of these relationships are, but when we actually have parallel lines, they actually become more significant. If we're looking at corresponding angles, these are angles that are kind of in the same location from intersection to intersection. So for example, if we're talking about a corresponding angle here, one example would be, we could say angle 4 and angle 8 are an example of corresponding angles. But if the lines are parallel to each other, these guys are also congruent. And that's actually also the case with a couple other pairs here. Alternate interior angles, we would say an example of these guys would be, for example, angle 4 and angle 5. Those guys are an alternate interior pair. But when we have parallel lines, these guys are also congruent. And actually, there is another pair that ends up being congruent. When we look at our alternate exterior angles, these guys also end up being congruent. Basically, our life becomes a lot easier when I look at a diagram and I have parallel lines because it's going to allow me to figure out what are some of the missing angle measures from intersection to intersection rather than just ones that all circle the same intersection point. Now, the only other one that actually doesn't end up being congruent are consecutive interior. These guys, if we're talking about an example here, consecutive interior, these would be, for example, like angle 4 and angle 6. So they don't actually end up being congruent to each other because we can also kind of tell even from here, this angle, angle 6, an acute angle, and angle 4 is an obtuse. So they, by definition, can't actually be congruent to each other, but they are supplementary. If we knew that angle 4 was 40 degrees, or not, that would make sense. If I talk about angle 6 being 40 degrees, then angle 4 would have to be 140 because they have to add to be 180. Now, all of these angle relationships are things we can add into our repertoire. And they're going to help me kind of work through some of these examples you guys see down below here. So let's look at example 1A here. It says the measure of 3 of the number angles is 125 degrees. Identify those angles and explain why. So what I want you guys to do right now is I want you guys to pause your video and I want you guys to see if you can figure out which 3 angles are also going to be 125 degrees. Pause your video now and give it a shot. All right, the 3 angles you should have said were also 125 degrees were angle 7, angle 1, and angle 5. Now, why is that? When we look at our angle relationships here, if I look at my diagram, it says which angle is also 125 degrees. Well, angle 7, if I look at my diagram over here, if I look at my intersection, angle 7 is in kind of the same location that angle that is measuring 125 degrees is also in. It just is moving from one intersection point to the other. So by corresponding angles, angle 7 is going to be 125 degrees. Angle 1 is not by any of the new ones that we've learned, but simply by vertical. If we have 2 lines that cross, angles that are opposite each other are always going to be congruent. Now, angle 5 is the other one. If I look at this angle right here, the angle that's 125, that is alternate interior with angle 5. Now, if these lines aren't parallel, then these aren't relationships that we could say exist. Because if they're not parallel, then we can't actually say that angles are for sure going to be congruent to each other because they could be different. Now, it doesn't change what their relationship is. The angle that's 125 degrees, those angles are still corresponding. These angles are still alternate interior, but they just wouldn't actually end up being congruent at the end of the day. But that's actually why for the second part of this question, it says, find the measure of angle 6 and explain why. Well, because we know that those lines are parallel, we can make those assumptions. I know that angle 7 has to be 125 degrees. I know that angle 5 has to be 125 degrees. And I know that angle 1 has to be 125 degrees. Now, we can use whatever relationship we need to explain what angle 6 degrees is. You might have noticed that these 2 angles, angle 6 and 7, are supplementary with each other. So really, ultimately, angle 6, if I take 180 minus 125, that is going to give me my final answer. Now, if we were comparing what those 2 angles were together, if I compare my angle that's 125 to angle 6, those angles are a perfect example of angles that are consecutive interior. And angles that are consecutive interior add to 180 degrees. So if we take 180 minus 125, that's going to give us our measure for angle 6, which is 55 degrees. All right. Now, what I want you guys to do, I want you guys to pause your video now, and I want you guys to see if you can come up with the measure of angle 2 for part B. Pause your video now and give it a shot. Now, let's see what we got here. We know now angle 2, we know no information about angle 2 to start, but we do have a lot of other information that's pretty helpful. The fact that we have these 2 parallel lines here. Now, that's actually something that I really should have mentioned. Parallel lines like this, we would have had to have these symbols on there, but they are parallel in this case. So because we have 2 lines that are parallel to each other, That means that all of the relationships that we see up above here are true. And any of them we can use to kind of help us. Now, specifically, I was looking at the two angles that involve x. We have this angle right here, and we have this angle right here. Now, those guys are a perfect example of angles that are alternate exterior. They're exterior because the angles themselves aren't between the two lines that are parallel. But also, if I look at my transversal, they're angles that are on opposite sides of it. The top angle 4x plus 72 is on this side. 13x minus 27 is on this side. So they're most definitely not consecutive. Consecutive means that they would be on the same side. So for us, if I set my equation, I know that alternate exterior angles are congruent. And that's why I set those two pieces equal to each other. For whatever 4x plus 72 is, that has to equal the same thing as 3x minus 27. So if we're going to go through and solve this guy, let's see what we actually end up getting. I'm going to take in my example here. We're going to take 4x plus 72. I'm going to subtract 4x over to this side. We're going to get 72, not 77, is equal to 9x minus 27. I'm then going to add 27 over to the other side. That's going to give me what, 99? And then last but not least, solving for x, I'm going to divide by 9 on both sides, and we get x to be 10. Now that I know x is 10, now I can figure out what my two missing segments are. Now keep in mind, those two angles that we have listed are actually congruent. So I really only need to do one of them. If I take 13x, 13 times 10 minus 27, I can figure out that this angle over here is going to end up being 103 degrees. Now, that's still not answering the question with what is the measure of angle 2. But here's what I do know. Angle 2 and this angle form an entirely straight line. They are supplementary with each other. So if I take 180 minus whatever we got for angle the 13x minus 27, which was 103 degrees, if I subtract those guys, we have found my measure for angle 2, which is angle 2 is going to equal 77 degrees. Now, in our notes for today, guys, you guys can cross off example C. We are not going to do this one. We're going to do this or look at a problem like this a little bit later in the year. But if you guys do scroll to the next page, you guys will see that I do have a couple you try nows. If you want to give these guys a shot, I am going to pause. If you want to pause the video now and try some of them, I am going to fill in the answers to this. And if you don't get the answers that you got, then please talk to me next week. But if you want to pause your video now and give a couple of these a shot, you may do so now. All right, guys, answers are up. If you have any questions about these, feel free to email me. But that is it for the notes for today. You guys can grab out your homework and you guys can start working on the 2.1 homework assignment for the day. Good luck, guys.